Okay, so practice matching bases method. And so 3 to the exponent 2x minus 5 equals 1. So I'm right now using the black blocks to kind of hide away some of my explanations. So for now, why do you think 1 can be represented as 3? Well, 1 can be represented as 3 because any number to the exponent 0 is equal to 1. So then you can allow it to have a base of 3. So any number to the exponent 0 equals 1. And so what we're basically doing is we are rewriting this so that now I have 3 to the exponent 2x minus 5 is equal to 3 to the exponent 0. When we have that, we could ignore the bases because the bases match. Since the bases match, I can say 2x minus 5 is equal to 3. Just look at the exponents and solve for the x. So I'm going to solve for x. Well, how do I do that? I am going to first move that 5 to the other side. And so I get a positive 5. I divide both sides by 2. And x is equal to 5 over 2. And that should be my final answer. And I'm going to do a left side, right side check. And hopefully it's pretty straightforward how you do a left side and right side check. And so you're just going to simply write the left side, right side, the t-chart. Write down the original equation and plug in your value of 5 over 2. What we notice is that the 2's cancel out and you have 5 minus 5 in your exponent. And so since you have 3 to the exponent 5 minus 5, well, 3 to the 0 is equal to 1. And so therefore, left side equals right side, which concludes that my answer is correct. That's part A. Part B. 5 to the exponent 4 minus x is equal to 5 to the x. Well, right away, without me having to do any modifications, I can just ignore the basis since the bases are matched. So what I'm simply going to do is write 4 minus x is equal to x. Next, I want to get the x's by itself, so I'm going to move that x to the other side. That way I have 4 is equal to 2x. I'm going to divide both sides by 2. And x is equal to 2. And that is my final answer. And just like before, I'll just do the left side, right side check again. Again, you set it up so that you have your t-chart. And then you plug in your value that you got, which was the 2. And we're noticing that we're getting 5 to 2 on both sides, which means that they are equal, and so my answer is correct. All right, part C. So I have 49 to the exponent x plus 5 on the right side and the rest on the left side. So is there any way that I can change it so that my bases are going to be the same? Can 49 be rewritten so that it has a base of 7? Well, 49 is a perfect square. Does that help? Well, 49 can be rewritten as 7 to the exponent 2. So what I'm going to use is the power of a power rule to emphasize this, meaning, well, I'm going to just rewrite the 7 2x times 7 3 minus x. And then what I have is, well, 49 is 7 to the exponent 2. And so I'm just going to keep brackets here so I don't lose it. I'm going to put it like this. Well, 7 to the exponent 2 has an exponent of x plus 5. I just rewrote 49 as 7 to the exponent 2. So therefore, what I'm doing is I am making a place where all of my bases are made out of the base 7. Next, I can't just start dismissing the 7s right away because I see 7 appear twice on the left side, and therefore I need to use this product rule. And product rule simply states that I can write the 7 once and I'm going to combine it so that I add up all of the exponent values, and so I get 7. Well, at this point I can do distributive property, because power of a power rule tells me that they're going to multiply anyway. So let me do that, and I get 7 to the exponent 2x plus 10. Now that we have this, now that I have one term equals one term where the bases are equal, I can ignore the bases. So I keep putting the ignore bases as a star because that's been like the consistent message throughout this lesson. And so I'm going to just have 2x plus 3 minus x, and I can do that because the bases are matching. And this is what I get. So next, I want to get my x's to one side. So I get x plus 3 is equal to 2x plus 10. I'm going to move the x's to one side. And I'm going to get rid of those. And then I get negative x plus 3 is equal to 10. And then I want to subtract 3 on both sides. And I should get negative x is equal to 7. You're going to divide both sides by negative 1. And x is equal to negative 7. And if you like, you can do a left side, right side check. So that's question C. Question D, we have the following. So we're seeing a lot of things now. We are seeing different bases, and it could look potentially hard. So first thing I need to note is that, well, with these two parts, I can't reduce, like I can't divide, I can't do 4 divided by 16 because the bases are different. And right now, the 4 has an exponent of x to it. So I can't simplify that in that way. Okay, so note that this has a 1 as an exponent. And so instead, what I'm going to do is, well, I can rewrite. And I'm noticing that 2 is like the lowest base that I have. And I'm going to rewrite 4 so that it is written as 2 to the exponent 2. I'm not done yet. I need to put the x there so it is exactly the same as the one above. Meanwhile, what do you know about 16? Can that be rewritten as a base of 2? Well, it can. It has a base of 2 and an exponent of 4. And that is equal to 2 to the exponent 3x plus 6. Okay, now it's kind of looking a little familiar and similar. And so keep in mind that I did use the power law and here, power law. Okay, so next I am going to combine the things on the left side. So I have 2 to the 2x because I did the power law. Divided by 4 is equal to 2 to the exponent 3x plus 6, like so. So what kind of rule did I just use? Well, what am I going to use now? Well, I need to apply the quotient rule. And so what I mean is, well, with the 2, I want to use the quotient rule so that I can rewrite this as 2 to the exponent 2x minus 4 is equal to 2 to the exponent 3x plus 6. So what do you think I'm going to say? Drop the base. Drop the bases. Okay, you have one term equals another term, and the bases are equal, so I can drop the base. And I will get 2x minus 4 is equal to 3x plus 6. I want to get my x's to one side, so I'm going to subtract 2x on both sides. I get negative 4 is equal to x plus 6. One more step of getting x by itself. And x is equal to negative 10. And so I have x is equal to negative 10. All right, question E. So again, the base that I'm seeing again and again is the value 5. Do you see what I'm seeing? I see 1 over 5, but I can rewrite that as a 5. 25, I can rewrite that as a 5. 125 has a relation to 5 as well. And that's why you're seeing these arrows that I already kind of started off. The reason I have the double arrows here is because, well, this has a negative exponent, which means if I flip the numerator and denominator, that is one way I can get that 5 to appear in the numerator. So that's the first thing that I'm going to do. So 5 to the exponent of, this just becomes a positive exponent 3x. Meanwhile, well, 25 can be rewritten as 5 to the exponent 2. And again, I want to keep the brackets here to the exponent x minus 1. And next, well, the reason I don't have a double arrow, but I just have a single arrow this way, is because this 125, remember, that's the same thing as writing 1 over 5, 3. And if I was to bring that up, well, then that's going to become 5 to the exponent negative 3. So I hope you can see why I'm doing the single arrow in that case. And so I'm going to have as the next line, well, I'm going to combine everything. So in this case, I'm going to do distributive property on that one. And so I will have 5 to the exponent 3x. That's the first part. Based on product law, I am going to add the second part in. So I really have 2x, because 2 times x is 2x. And then 2 times negative 1 is negative 2. And then I have 5 to the negative 3 on the right side. So I'm going to simplify the exponent. So I get 5 to the exponent 5x minus 2 is equal to 5 to the negative 3. I'm going to say drop the base. Drop the bases. And so I'm going to have 5x minus 2 is equal to negative 3. I'm going to get x by itself. So I'm going to add 2 to both sides. I have 5x is equal to negative 1. How do you get x by itself? Well, I want to divide by 5, and therefore x is equal to negative 1 over 5. And that is my final answer. All right, last question. All right, so you're going to be a little surprised that I'm going to say this, but I look at it, and the one thing I notice is that this is a subtraction. And is there any laws that helps us with subtraction between the two powers? Okay, so I'm just gonna write here, this is hard. I mean, this might have been easier if this was a multiplication or division, because we could apply product and quotient law. So I'm just gonna leave it there and say this might require us to advanced function knowledge. And so I'm just going to leave it out in the open as like a line, because this might be more of an advanced function question, but I'll leave that as a cliffhanger.